Welcome to our AS Skeleton Code, where we dissect and explain the code to help you all with your A levels. Today, we'll be delving into the inner workings of the queue simulation program. Now, let me break it down for you. Imagine you're at a busy supermarket. There are multiple checkout lanes with customers waiting in line. Now, think about all the factors at play here: the arrival of new customers, the time it takes to serve each customer, and the overall efficiency of the checkout process. This is where our Python program comes into play. This queue simulation program allows us to model and analyze the dynamics of a queue system, just like the one we see at the supermarket. But it's not just about understanding how queues work, it's about optimizing them for maximum efficiency. At the heart of our program lies the queue simulator function. This function orchestrates the entire simulation process, from simulating customer arrivals to managing checkout lanes and tracking key statistics. Throughout the code, we'll encounter various sections that handle different aspects of the simulation, from initializing simulation variables to serving customers and handling remaining buyers and tails. Now let's start with the queue simulator subroutine.
Initially, in the queue simulator subroutine, the two variables buyer number and queue length are initialized and set to 0. Then the reset data structure subroutine is run. In the reset data structure subroutine, 3 arrays are being initialized. First is the stats array, which is a 1D array in which 10 values are being created, 4 of which are unused. The array stores the statistics shown above and has assigned index positions for each statistic. Second is tills, which is a 2D array. In tills, each column contains 3 rows, which are time idle, time busy, and time serving. The third array is buyer queue, which is an array containing 30 buyer objects that have been initialized with the queue node class. Each attribute of each buyer is set in accordance to the constructor method of the class.
The change settings subroutine offers the user to change any settings related to the simulation time and the number of tills. The default settings are 10 time units for simulation time and 2 tills in operation. There is some validation as the program checks that the user-chosen simulation time does not exceed the maximum time of 50 time units, and that the maximum of 5 tills is not exceeded. However, there is no validation for if non-integer values are entered. The error caused by entering a non-integer value can be prevented using a try and accept, where a value error is accepted.
The read-in simulation data subroutine creates a 2D array in which the data of all customers will be stored. The subroutine opens a file containing all the details related to the customers and the number of items they have. File in readLine reads the first line and assigns it to the data string variable. Each row of the 2D array contains arrival time and number of items. The reason why max time plus 1 is used as a repeating unit in the for loop is because the first row is just ignored and the code just starts with B1, which is customer 1. Then a while loop is used as it keeps looping through the file until the entire file has been read or the time available has elapsed. The code in the while loop extracts information from the data string variable, which is representing the current customer's data. The second line of the while loop extracts the arrival time of each customer and assigns it to the corresponding index in the 2D array. The third line retrieves the number of items each customer has using slicing to exclude the time and the colon in the original file. Then the file read line reads the next line in the file, which is now adding the next customer, where count also increases by 1.
The variable time to next arrival is allocated the arrival time of the first buyer in the data array. These values in the data array have been imported from the simulation data text file. The simulation is initiated through a for loop, where each iteration of the for loop is a time unit. The number of times that the for loop iterates is decided by the simulation time, which is initially decided by the change settings function. At the beginning of each iteration, which is essentially a discrete time unit, the times to next arrival variable has its value decreased by 1, as there is 1 less time unit before the buyer arrives. If the time to next arrival is equal to 0 after it has been decreased by 1, this indicates that a buyer has arrived. In order to ensure that the index position in the data array for the arrival of the next buyer is accurate, buyer number is incremented by 1. When a buyer arrives, the buyer arrives subroutine is called. The first line of the buyer arrives subroutine employs the use of an f string to display the buyer number value and the number of items they have arrived with. The number of items is obtained from the data array. The second line of the subroutine calls the buyer joins queue subroutine.
Firstly, the number of items allocated to the current buyer is stored in the variable items in basket. The subroutine then proceeds to modify the buyer queue array, which contains 30 blank objects that have 3 attributes each. Buyer queue length refers to the next available position in the queue. Therefore, the next available blank object's attributes are modified to store the buyer number and items in basket of the current buyer. Lastly, queue length is incremented by 1 to increase the length of the queue as there is now one more buyer in the queue.
The find_free_till subroutine is responsible for locating an available till that is not currently serving any buyer. In find_free_till, the variable found_free_till is used to track if a free till has been found, and the boolean value false means that currently no free till is available. The while loop iterates through the tills until a free till is found, or until all tills have been checked, and if found_free_till is equal to true, the till number won't increase, and the index position of the till that is free is returned. The if statement checks if the current till being examined is not serving any buyer. If a free till is found, this flag is set to true and the index of the free till that was found is also returned. If no free till is found after checking all tills, then the value -1 is returned to indicate that there are no available tills.
The purpose of the serve buyer subroutine is to simulate the process of serving a buyer in the checkout system, update the queue of buyers after serving one buyer, and provide information about the served buyer to be used for statistical analysis and output. Initially, 3 local variables are initialized, and the subroutine accesses the first object in the buyer queue array, which represents the first customer. All local variables are assigned with specific attributes such as their ID, waiting time, and items in the basket. Then the for loop loops through the queue length to shift each buyer 1 space forward in the queue. This is done by using count and count plus 1. For example, in the first loop, count is equal to 0, which means that the customer who is in the queue after the current customer, which is represented by the index position 1, will now be moved to index position 0. Then the last index position in the array is cleared as they have been moved up, and this is now open for anyone new to join the queue. The queue length variable then decreases by 1 as one buyer has been served and removed from the queue.
The main purpose of the update stats subroutine is to simply update the changes that have occurred after a customer has been served. This can be to do with the total waiting time experienced or even if the customer had to queue or not. This is mainly done by amending the stats array through the use of if conditions. First, the waiting time of the last customer is added to the total waiting time index in the stats array. Then the waiting time of the last customer is compared to the max waiting time so far and is changed if the time is greater. And finally, if the waiting time of the current buyer is 0, meaning that the buyer didn't have to wait at all, the subroutine increments the count of buyers who didn't have to wait in the stats array.
The purpose of the calculate serving time subroutine is to determine the time it takes to serve a customer based on the number of items they have. It calculates the serving time using the formula number of items divided by till speed plus 1, where number of items is the number of items the customer has and till speed is a constant representing the speed at which items are processed at the till. In the subroutine, integer division is used and the result is incremented by 1 to ensure that even if there's a remainder in the division, the serving time is rounded up to the next integer. Then the serving time for the specific till in the tills array is updated and also printed using an F string to display the till number and the corresponding serving time.
This subroutine is called by the serving subroutine. It is called when all tills are busy and therefore any items that still remain in the queue are waited to be processed for one more time unit. The subroutine loops through each buyer in the buyer queue array and increments the waiting time attribute by 1. The code ensures that objects in the array that have not been assigned to a buyer, they are essentially blank, do not have their waiting time increased by 1, as the range of the for loop is only up till the value of queue length, which stores how many bars are in the queue at that period in time.
Update tills is another subroutine that is called by the serving subroutine. It is called right after the increment time waiting function and therefore is only called when all tills are busy. This function proceeds to loop through every till that has been initialized by the change settings function. Here, number of tills plus 1 is used as the first item in the tills array is blank. The subroutine checks whether the time serving value of each till is equal to 0. This is only possible if the till is not currently being used in the time unit and therefore the time idle value is incremented by 1 if it is not being used. However, if the till is being used by a buyer, meaning that time serving is greater than 0, the time busy value of the till is increased by 1, as it is being used by the buyer for one more time unit. Furthermore, since the till is processing the buyer's items during this time unit, there is one less time unit remaining to serve the buyer. Hence, the time serving value of the till is decreased by 1.
This procedure is called at the end of the serving subroutine. This is when the time unit is about to end. In order to allow the user to access information about the simulation after each time unit, the program outputs the states of all the tills and the buyer queue array. Firstly, the program loops through every till and employs the use of f-strings and formatting to display its time idle, time serving, and time busy values. The program then proceeds to loop through all the objects in the buyer queue array. As mentioned before, the program excludes any blank objects by setting the range for the for loop to queue length to make sure that the last object checked is not blank. All three attributes of each buyer in the queue are displayed with formatting. These attributes are buyer ID, waiting time, and items in basket. This subroutine is a procedure and not a function, as it does not return a value. Its sole function is to output information. It is therefore not required to modify any data structures, and therefore no values are required by any other subroutines or the main program.
The serving subroutine can almost be described as an admin, as it is responsible for calling most of the subroutines present in the program. As all of the subroutines called by the serving function have been explained in other parts of the video, we will cover the parts that are exclusive to this function. The while loop used at the beginning of the function is used to validate that at least one till is free to process a buyer in the queue, and that there's a buyer present in the queue for a till to process, meaning that queue length is greater than 0. Moreover, after the values of each till has been updated, the program increments total queue occurrence from the stats array by 1, as long as there is still a buyer present in the queue. The validation to check if a buyer is present in the queue is important, as if a buyer entered the queue in the time unit and was processed by a till in the same time unit, it technically did not have to wait in the queue. Also, the length of the queue is added to the value of total queue, as total queue is the total number of buyers that have had to queue up during the simulation.
This subroutine is called by the queue simulator procedure. It is only called after all previously allocated time units have been looped through. Its main purpose is to check whether any tills are still processing items after the allocated time units have passed, as this would mean that the simulation will require extra time to ensure all the buyers have their items processed. Before the subroutine is called, it is ensured that the queue is empty. At the beginning of the subroutine, a boolean value, is busy, is set to false. The number of tills looped through by the code is decided by the number of tills variable that was set to a value in the change settings function. Each of the tills that may have been used by the simulation is looped through, and each time-serving value is checked. This value indicates whether the till still requires any more time to finish processing the buyer's items. If the time-serving value is greater than 0, the isBusy boolean value is set to true. This causes the while loop to terminate before its next repetition begins. The queue simulator function ensures that the simulation does not end until all tills are free, therefore all time-serving values are 0. Once the decided number of time units has been looped through, the program checks whether there are still any buyers in the queue. This is done with the statement while queue length greater than 0. If there are still buyers in the queue, the simulation is allocated some extra time. Every new time unit is used in extra time is printed using formatting. The serving subroutine is called in every extra time unit until the queue is empty. The extra time variable is increased by 1 after each extra time unit to allow the programmer to know how much extra time has been used by the program. This may potentially be used to calculate other statistics if the simulation is further modified. Lastly, the code checks if any tills are still busy processing a buyer's items. This is done using the tills busy subroutine that is discussed in another part of this video. If there are still busy tills, the simulation is allocated more extra time, and the tills are updated using the update till subroutine after every extra time unit. The state of the queue and all tills is also outputted after every extra time unit.
This subroutine is the last subroutine to be called by the simulation. It is called at the end of the queue simulator procedure. Its purpose is to output all values of the stats array, which contain different values that have been modified throughout the simulation. Each statistic is outputted using a print statement that utilizes an if string. The total wait time is not outputted. Instead, an average waiting time for each buyer is calculated by dividing the total wait value by the total number of buyers in the simulation. A round function is used to ensure that the value is outputted to one decimal place. Furthermore, total queue and total queue occurrence are not outputted by the subroutine. Instead, these two statistics are used to calculate an average queue length by dividing the total number of buyers that had to queue up during the simulation by the total number of occurrences where the buyers had to queue. This average queue length value is outputted to 2 decimal places.
So that brings our analysis and explanation of the 2024 AS skeleton code to an end. We hope that we were successful in erasing any doubts that you had about the code. Thank you for watching, and please like and subscribe.